Welcome to RCR Wireless News. I'm Martha DeGrasse, and our topic today is DAS and small cells. I'd like to introduce you to your panelists for today. Alan Law is chair of the Small Cell Forum. Alan, thank you very much for being part of the webinar today.
Thank you, Martha.
Earl Lum is president of EJL Wireless Research. Earl, thank you very much for being here.
It's great to be here, too. Thank you.
Scott Sumner represents Accedian Networks, one of our sponsors today. He is VP of Marketing. Scott, thanks for being on the webinar.
Thank you, Martha. Nice to be joining you today.
Ixia is another sponsor today, and Pierre Lynch is lead technologist of Ixia's product management group. Pierre, it's great to have you back.
Thanks, Martha. Happy to be here.
And Ray Hild is here today representing sponsor Galtronics. Ray is VP of Sales for North America. Ray, welcome to our webinar.
Thank you, Martha. Pleasure to be here.
And I'm Martha DeGrasse for RCR Wireless News. A quick word about RCR Wireless News. We are a premier news source for the wireless communications industry, published since 1982. Find us at rcrwireless.com, on Twitter at RCR Wireless News, and find RCR TV on YouTube. I'd also like to call your attention to a feature report which is on our website on DAS and small cells. Quickly, I'd like to go over a few key takeaways from this report. You can download this at the rcrwireless.com website by clicking on the Reports tab at the top. The line between DAS and small cells is blurring. I think a lot of people are seeing this both indoors and outdoors. And a lot of this also has to do with the definitions of DAS and small cells, which is something we're going to go over a lot today in this webinar. Industry participants do not necessarily agree on the market outlook. You see this most clearly with the tower companies. SBA recently got out of the small cell and DAS business by selling its stake in Extenet to Vertical Bridge. Meanwhile, American Tower and Crown Castle continue to invest. Crown has been in particular a buyer of fiber assets to support its DAS and small cell deployments. On the carrier side, we've seen AT&T back away from its plan to deploy 40,000 small cells. And the carrier has also stopped many of the activities of its Antenna Solutions group, which was working to deploy neutral host DAS. Verizon, though, has continued to invest in DAS and small cells. And we are going to list later in the webinar the U.S. markets in which Verizon is planning or already deploying small cells. T-Mobile said at CTIA that it has not even started thinking about small cells seriously until about 12 months ago. And Sprint has said that it will deploy tens of thousands of small cells in the U.S., leveraging SoftBank's experience in Japan. The carrier has said it will use big data and network diagnostics to find the right locations, but it has not started naming these locations. DAS vendors are looking to the enterprise customer. Carrier spending on new distributed antenna systems has slowed during the past year, and vendors are working hard to help the enterprise understand the value proposition. And network architectures are evolving to support the enterprise need. We're seeing more deployments in which the baseband is separated from the access nodes, and that frees up valuable real estate. And finally, small cells present new challenges for testing and optimization. The equipment and the processes used to test macro sites are often not cost-effective for small cells. And that is also something that we're going to hear more about in this webinar. Now, at this time, I'd like to turn the presentation over to Alan Law of the Small Cell Forum.
Thank you very much, Martha. So now what I'll do is I'll spend the next 2 or 3 minutes really giving you an introduction to what the Small Cell Forum is all about. Really, so what do we do? We're an organization. We have 150 member companies that represent all parts of the ecosystem. So everybody that makes chips and component parts, to integrating the solutions, to providing end-to-end solutions, to the operators that run those solutions, and people that provide software for those solutions. So we have a very broad stroke of membership. In terms of what we do, we drive standards. So what we're doing there very much is we're looking for either where the standards are progressing slowly or are there gaps, and we work to address that. We also release documents that are very much about removing the barriers to small cell adoption. So whether that's a business case, whether that's a technical understanding around how to deploy, or around how to manage interference to get the most out of those systems, that's very much part of our release program, that we release documents to do that. And then finally, it's around promoting solutions. So, our release program has started off very much looking at the deployment use cases of residential, enterprise, urban, and rural and remote. and really providing the insight that operators would need and companies within that ecosystem to understand how the whole system hung together and how to really do it and to do that successfully. If you can move to the next slide, please. In terms of success, we're extremely pleased with the progress we've made to date. You know, there are over 11 million small cells deployed worldwide right now, and we're seeing growth in every sector. We're seeing growth in enterprise, residential, rural and remote, and urban. And in fact, the projection that we look at that comes from Mobile Experts predicts effectively it'll grow by a third roughly each year. In terms of how the industry is changing, very much from when we started, it was all about small cells, but right now, what you see from operators in the way they deploy their assets, it's actually more complicated than that. And what you effectively have is a broad spectrum of solutions that you need to work extremely well together to get the maximum performance out of that integrated HETnet. And that very much forms the core of the future work within the Small Cell Forum. If you want to hit the next slide. Very much the work that we do, it's all about commercializing the network edge. So it's really looking at the technologies that you have and what to do with those to really make it pay and have the impact that you want in the industry. We're extremely proud that we're an operator-led organization where we base our work really on the drivers of our operator membership. And as you can see, you know, there in terms of the carrier requirements and demand, it is this broad spectrum of integrated HETnet that we have to deliver. And as a forum itself, our mission, just to reiterate, it's about driving that wide-scale adoption of small cells and really accelerating the delivery of those integrated HETnets. So thank you.
Thank you very much, Alan. Now we're going to hear an introduction from analyst Earl of EJL Wireless Research.
Thank you, Martha. So basically, EJL Wireless Research is a market research and consulting company. You can find us on the web at ejlwireless.com. Our perspective of looking at all of the solutions that are out there for both the macro cell, the DAS, and outdoor and indoor really centers upon a toolkit approach where, depending on the building size, depending on if one or more operators need to be inside that building or outside in the city area or the metro area, then depending on, again, what interface technology need to be deployed, whether it's a combination of 2G, 3G, and 4G plus, or whatever it may be, there is a solution that would fit the right economics for that particular deployment. And so our perspective is that the world in wireless is very gray and blurred, and not one technology will always be the preferred solution. It really depends on the specific building and what the requirements are when you're talking in building. And then if you're talking outdoor, again, it depends on what the situation is with site acquisition and all the other issues that the industry has been coping with for the last several years. Can we go to the next slide, please? So our perspective is that, again, there's a mix of different technologies that can be utilized depending on if you're outdoor, indoor, if you need Wi-Fi, if you don't need Wi-Fi, if you're going to be using active or passive DAS solutions for in-building or small cells or solutions that have come out now with the base station OEMs. So there is a wide variety which adds to the confusion of what is potentially the best technology that's going to be out there for the enterprise market, specifically when we're now seeing the shift and the burden of the deployment going to the landlords and the building owners. Can we go to the next slide, please? This is kind of a very simplistic view of looking at the in-building wireless market in terms of where some of on the right code and where they fit into the different tiers of building sizes, the different verticals for the enterprise market. And as you can see, when it comes down to the deployment at a particular point in time, the overriding factor of all of these solutions is what is the cost per square foot that we're looking at specifically from a North American perspective, and which particular product would meet that cost target, in addition to supporting the multitude of operators and technologies that need to be deployed within that particular building. And with that, I'll turn it back to you, Martha. Thank you.
Okay, thank you very much, Earl. Now, before we launch into our discussion for today, we're going to hear briefly from each of our sponsors, starting with Scott Sumner of Accedian Networks. Scott?
Thank you, Martha. I just wanted to take the opportunity here to share some insight that we have as a performance assurance vendor working with a lot of the leading mobile operators worldwide. We work with 18 of the top 20 worldwide, as well as many of the small cell and macro cell backhaul providers. So a lot of insight we've seen across the globe. One of the ones in terms of challenges we were aware of that's acute in the operator's mind is how the backhaul chain itself is getting longer as small cells extend from macro sites and add additional connections, processing time, and latency. At the same time, though, as we move towards 5G specs, we'll need to see tighter latency between sites and also improve performance. So there's a bit of a contradiction in requirements there. And at the same time, there's a cost objective that needs to be met so that you can be operationally efficient and deploy small cells as quickly as possible, but without sacrificing quality. Another compounding factor here that we've talked about a little bit now is the multiple types of backhaul technologies and options available that will necessarily be required to address small cell backhaul in a cost-effective way. So everything from customers' lands on the internet carrying the backhaul traffic to a certain point, small cells as a service or alternate access providers, a lot of different ways and technologies will be required to combine together to reach all these different cells. So the ultimate conclusion of that is that there is a really critical element of cost here to make sure that the small cells rollout is done cost effectively. But as things get more complex, the visibility level decreases. And ultimately, this creates a lot of challenges in terms of maintaining quality of service when visibility is really required to optimize a more complex network. So in terms of our solutions and how we've seen operators deal with this extensibility of the network, turning up small cell backhaul is extremely critical in terms of cost and efficiency. So the ability to go out there and have an untrained technician really plug in the demarcation point in the small cell and have it automatically generate multi-flow test streams and validate and turn up of the small cell or the headnet element from the day one onwards is a critical aspect to that. And also the ability to test one way in between sites is something that's going to be necessary as the X2 interface and communication between cells needs to be coordinated more efficiently. And being able to do this at any time of day, so realistic testing at peak hour that allows you to move ahead without having to wait for maintenance windows to bring new small cells online. So in addition to that, there's the performance monitoring that needs to occur in a long-term basis for ongoing trending, optimization, and really the ability to offer multiple classes of service of backhaul to each of the small cells at the same level you would need for the macro site, but also keeping SLAs in check, either if you're a wholesale provider doing backhaul or internal SLAs to make sure that metrics that need to meet certain specific performance criteria are consistently met and optimized as the network grows, as traffic increases, and as multiple applications will compete for the network. Thanks, Martha.
Thank you very much, Scott. Now we're going to hear from Pierre Lynch of Ixia. Pierre?
Hi, thanks, Martha. I just want to quickly introduce Ixia. We're a company of about 1,800 people worldwide based on NASDAQ. We're a networking company focused on application performance, security, resilience, and how we do that is we help our customers validate, secure, and optimize their networks in a pre-deployment and post-deployment cases. Our customer list encompasses network equipment manufacturers, carriers, and service providers, as well as enterprise. And specifically in small cells, we have a series of tools for pre-deployment testing of the entire LTE network from end to end, including the eNodeB small cells and residential gateways and small cell gateways, as well as Wi-Fi, air interface, and network testing. And lastly, we are members of the Small Cell Forum.
All right, great. Thank you very much, Pierre. And now we're going to hear from Ray Hill, VP Sales at Galtronics. Ray?
Thank you, Martha. I just want to say thank you to RCR, my colleagues, and especially to those of you who took time out of your day to spend it with us. Some good points made in the prior comments. From Galtronics' perspective, the company takes a consultative approach, and we want to partner with, and do partner with, a lot of the OEMs that make the small cell product that our colleagues are talking about this morning, and also the carriers and the neutral host providers as well that Martha alluded to earlier in the introduction. When we take a look at it from an antenna perspective, it's all about the propagation, the KPIs, the form factors, and the cost per square foot at the edge as well. So we kind of look at it from the end back to the beginning and the impact of that edge. So we provide a myriad of products, some of which you see on the screen right now, whether it be for small cell, outdoor DAS, indoor DAS, stadium, regardless of application. So our role in all of this is to make for sure that the edge complements everything that my colleagues said in the beginning. And Galtronics was founded 37 years ago. That's all we do is make antennas for LMR radios, networking, telemetry, mobile devices, outdoor, stadium, in-building, and small cell. Thank you, Martha.
Thank you very much, Ray. We look forward to hearing more of your comments later in the webinar. At this time, we are going to launch into our discussion, and we're going to start off with basic definitions because there are some areas of confusion around the topics of small cells and DAS. So appropriately, Ellen, we'll start with you to try to get a definition of small cells from the Small Cell Forum.
Hi, thank you very much, Martha. So starting with the first question then, which was very much about small cells with an integrated modem compared to a small cell as an access node. And very much you can think of this in the sense of the small cell access node being the classic base station architecture, which has been deployed for many years in the network. And then the integrated modem case being largely where you've integrated some of the higher layers that are within the specifications within a small cell product to help it scale and move forward. In essence, really, the small cell definition has evolved over time, and whilst at the beginning, prior to the Small Cell Forum, we were the Femto Forum, where very much it was focused on that integrated node being the focus, and Femto, as the definition has now expanded to small cell, then very much it's encompassing in essence, any, you could say, logical architecture that allows you effectively to deploy and have high experience within a localized area, which typically maps to a lower output power from those small cell products.
Okay, great. One thing that we do hear a lot about from a lot of vendors is small cells as a service, particularly in an enterprise environment. And Scott, I think that you have some experience with this. Can you share a little bit about your experience working with different service providers who want to offer small cells as a service? Scott, can you hear us?
Yes, thanks, Martha. One thing that's hampering small cell deployment with a lot of service providers, at least on a large scale basis, is access to, well, I guess in outdoor, it's access to power, it's access to tower locations, it's access to backhaul as well. And in indoor, sometimes the same challenges apply in terms of space and wiring and availability to access different locations. Small cells as a service is really a new thing we're starting to see emerge. We're working with Cox Communications on this, and they've been rolling out small cells as a service over the past few months, where they really intend to accelerate small cell deployment by eliminating those barriers towards regulatory problems and mounting hardware, and how they can bring cost-efficient, rapidly provisioned backhaul to many locations that are served by their cable MSO plants. So as an example, they can basically turn small cells up in a few months that would normally take 18 to 24 months in terms of the planning and regulatory phases. And the turn-up of the small cell itself actually just takes a number of hours, which is an amazing achievement. So I think this fully integrated vertical approach of a small cell as a service, where you either host it yourself or you provide the turnkey solution to an end operator, is going to make a big difference, at least in terms of North American deployments over the next several months.
Okay, great. And then are you also seeing some vendors describe small cells as a service more based on the actual services that are enabled by small cells, like the unified communications, the mobile device management, those types of things? Because I think some people, when they talk about small cells as a service, they really mean what's enabled by that, right?
Yeah, there's always a little bit of haziness when we get into the as a service acronyms for sure, but there are new services that are being brought in because of small cells, and I guess some of the most interesting ones, things like you were talking about, unified communications, ones that are very latency sensitive, require quite a bit of precision in the backhaul and the control plane, are actually still being handled by the macro sites. So the small cells are unloading or offloading a lot of the services that are less time critical, so that these newer, more latency sensitive ones can be reached from the macro tower with more power available to each user to make sure those services are maintained well.
Okay, that's interesting. Thank you. Okay, another definition area that I think is worth touching on is small cells versus DAS remotes. I know that some tower companies refer to small cells, but the equipment is the same equipment that others might call a small cell. So, Alan, can you enlighten us a little bit on these definitions?
Yeah, sure. So, small cell versus DAS remote unit. Then, continuing with the definition of the small cell being where you effectively have the higher layers integrated that you're using to provide your 3G, 4G, LTE service to your customers. And there are architectures within small cells, and with those, when the capability is integrated, to effectively allow you to connect that to multiple operators, which is the typical use case that sits around DAS remote units. So there are a couple of capabilities within the standards called MORAN and MOCAN that allow you to do that, and there are small cell products available today that allow you to do that. Now with the DAS remote unit, what you effectively have is your antenna component connected by some form of cabling together with a main unit. And what the subtle difference here is what you tend to do is the operators will connect their existing base station infrastructure into the DAS remote unit, and that will be used to effectively transmit the signals and radiate. And that gives great flexibility in the sense of operators, particularly in vendor choice across multiple operators. I think the fascinating thing at the moment is, as you're moving to a virtualized world, what you're starting to see is and you decompose the small cell and the DAS becomes more active, that actually these worlds are coming much closer together. And it's certainly an area we're exploring within the forum.
Okay, great. Thank you. And Earl, I know that you've also looked a lot at the way these are coming together. Do you have anything to add to this?
Sure, Martha. I think originally when the notion of HetNet came out in the industry, the small cell was really primarily defined from an RF output power perspective, with microcells typically in this 5 to 10 watt range, and then picocells in the 1 to 2 watt range, and then femtocells kind of in the milliwatt or several hundred milliwatt range. I think at this point, kind of further dovetailing into what Alan just spoke about, if you talk about a DAS remote unit at this point today, it is essentially a radio transceiver with multiple bands of amplifiers that are then connected to a wideband antenna. So that particular remote unit is only doing the RF portion. There is no essentially layer 2 or layer 3 functionality that is in that unit. So it's only doing the RF transmit and the RF receive. On some of the more traditional small cells that may have those integrated baseband capabilities, that then makes those particular small cells potentially limited if they're only 4G capable, and then you would need to look at what is the requirement if it's multi-RAT in terms of meeting those requirements. On the DAS remote side, since it's RF only, it's agnostic to virtually any air interface, and all it's doing is just pumping out the RF signal through the antenna. So thereby, you're able to hook in multiple operators on that remote radio unit, each with this 5 megahertz channel or whatever amount of channels that you need. So that's a very distinctive difference in terms of the definition of a DAS remote unit relative to a small cell that may be single band only, or maybe it only has 2 or 3 bands, and then can it also support multiple operators?
Okay, great. Thank you. No, Alan was talking a little bit about decomposing some of these units, and I think that's given rise to the concept of Fronthaul, which needs to be understood different from Backhaul. Pierre, can you go over that a little bit, Fronthaul versus Backhaul?
Yeah, sure. Simplistically, the backhaul is a transport network that allows the transmission of the packets from the small cells or whatever, the macro as well, back to the core network. There may be other elements in between, and the backhaul may be used for inter-eNode B communication as well. Mechanisms used here are either everything from cable internet to Ethernet itself, to microwave, millimeter wave wireless solutions, line of sight and non-line of sight. Fronthaul is a brand new concept born out of virtualization, where the eNode B, or the small cell, will be divided into a virtualized part that sits in a closet in a data center somewhere, versus a physical network function, or a PNF, which is typically radio and maybe something else as far as functionality. And the Fronthaul is the transport network required to make those communicate together.
Okay, great. And can you give us a little bit of information about how this fits into a centralized RAN?
Absolutely. The centralized RAN concept is totally a virtualization concept born out of both Ixia NFV and also NGMN talked about it quite a bit. And the purpose is to virtualize a cell, virtualize a base station or eNode B, and in our case, a small cell, by dividing the functionality of the physical network function, which as Ixia and NGMN defined it, was just remote radio heads remotely connected to centralized virtualized functions that would carry out all the rest of the functionality of an eNode B. The original definition is it requires very high capacity backhaul, so it's kind of like a CPRI transport, which is very high demand on bandwidth and latency. But there are other alternatives that we may talk about later. But basically, CRAN is fully virtualizing the eNode B, along with all the benefits that come with that, including running in a virtualized environment on COTS servers, the management and operational aspects, the automation aspects, dynamic scaling, etc.
But can't you also centralize the radio access network without necessarily virtualizing it, just centralizing it in one remote location?
Correct. You can centralize the units, but then you don't have the benefits of the virtualization, running other types of services in those same on those same servers. So having multi-tenant situations, whatever types of services you want to provide at the edge, things that are being developed by the Small Cell Forum and MEC, Mobile Edge Computing.
So the virtualization is perhaps what distinguishes it from a baseband unit hotel, or a place where all the baseband units are just centralized. Is that right?
That is correct.
Okay, great. Thank you very much. Now, at this time, we're going to move on and talk about indoor solutions. And Scott, I'd like to direct the first question to you. We know that the enterprise is an increasingly important customer for vendors, and I'm wondering if, in your opinion, if enterprises are coming to understand the value proposition for indoor solutions.
I think we're starting to see this more and more. What's becoming an interesting trend, at least in the carrier Ethernet market that's serving the backhaul, just as a parallel, is that we're starting to see a lot more real-time reporting on connectivity services, on business Ethernet services. And you're starting to see the same thing in terms of mobile operators are starting to emphasize their value to their customers through the performance of the network itself. And as we start seeing more of this kind of quantified ROI-based reporting in terms of metrics and network performance, and ultimately the user experience, the end users are becoming increasingly aware of which operators are able to do this, and the metrics that are used to differentiate each from each other. And in a time where there's so many different ways to communicate in terms of voice and audio, and also the different wireless technologies, the service providers have to emphasize what their difference is in terms of differentiated performance, and really express that to their customers with some real-time visibility of what difference they're making to them. So as these systems become available, as they start to deploy real-time reporting systems and portals and so on for their traditional services, they'll be able to more easily express the value to enterprises in terms of what the small cell that they'll deploy on their sites will mean in terms of productivity or download speed or quality of experience or call drops or any of these key metrics for customer experience management. So I think that's really the idea here, is to have them use their own visibility and expose that more to the customers, have the customers buy in and realize that there's so much more that they can be done with their connections once they have a top performing access point.
Okay, great. And Ray, how can the vendors help the enterprises understand what more can be done with their connections and how they can really add value through these indoor solutions?
And that is the question. The ROI, we have to, first of all, I think the industry, all of us need to look at it from the enterprise's perspective. And their point of view, first of all, starts with their technology plan and their own personal corporate objectives. And they've established those. So we need to define an upgrade path from today until tomorrow to get them from point A to point B. So it starts with understanding where they want to be in the next 1 to 3 to 5 years. And what is the ROI, and what is and how does convergence play into that ROI? So for example, as Earl alluded to earlier, if you have a tier 2 facility that's 250,000 square feet and it's one of many owned by a REIT in a certain market, what is the connectivity between those facilities? Who are the clients they're serving? What about BYOD? What kind of drivers, what kind of applications they want to roll out on these particular systems? Because what we've seen in the past as we've deployed legacy systems is we've pulled many times in the ceilings to enable public safety, to enable DAS, to enable Wi-Fi. And now we've seen building monitoring and controls. The question becomes is how as an industry, whether it be small cell or other toolkit approaches, can we pull once and potentially enable many things?
Earl, do you have any insight on that?
Yeah, Martha, I think from, if you, again, looking at what Ray was discussing and looking at the different enterprise verticals, the question becomes, what is that wireless doing? And in some cases, is that wireless now viewed as a utility? And from the perspective of the REIT owner of that building not being able to get tenants if there's no connectivity inside. I think most of us would agree that no one would check into a hotel today if they did not have Wi-Fi available for us to use, and certainly if our mobile phones did not operate in that building, we probably would think about going to a different venue from a hotel perspective if we weren't able to use our cell phones inside the hotel rooms. And I think the question then becomes, what does that enterprise need to have as a minimum configuration for wireless inside their building? What is the budget of that? And then now layered on top, any new requirements that come from the public safety perspective are all going to play into how much can they afford to roll out and what is the right solution for them to be able to meet those coverage requirements.
So do a lot of enterprises need to budget separately for public safety systems if they are required to have that, Ray?
Well, yes, there's actually rules and regulations that have been in place post 9/11 in many markets, municipalities around the United States, that they require under certain circumstances that radios work in premise. From my personal perspective, I think that public safety is not just a first responder question. Everybody in the industry, everybody in the community needs to budget for, respond to, and make available a public safety response. And Earl mentioned utility. I would submit that this is one as well.
Earl, what do you think?
I think right now one of the issues is, can the current wireless system that's being proposed supplement or include public safety? What does that do to the dollar per square foot cost for the building owner? as they look into the budgeting of that. And then obviously the deployments of the public safety nodes are less of an issue of capacity relative to coverage, and the requirements of where that equipment sits in the building itself is certainly different than for the DAS system or small cells or whatever else that may go in there. So there's certainly a different cost adder that gets lumped into the overall pie that needs to be budgeted out. And again, given the regulations and rules that have to be there, it may be a critical gating item for that building owner to be able to actually get tenants to move in if it doesn't get signed off that it has public safety available. And if there's a fire marshal check or whatever is required and that checkbox isn't checked off, then does that become a serious situation for the building owner in order to get tenants to move into their building?
And are you starting to see that in some situations?
I think we are starting to see much more of the building owners really looking at what they need to do, and again, it depends on the location, what states they're in, and what the regulations are for the different municipalities that they're located in. But it's certainly something that's coming up now that really probably was unfortunately more ignored in the past, but it's being brought to the front of all of the issues that need to be addressed as one looks at in-building wireless as a complete solution.
Right, good point, Earl. This is Ray again. So Martha, there's two other driving forces here too, from a public safety perspective, meaning first responders. You have police and fire and others who have their agendas and their need for redundant networks. And in addition to that, you have FirstNet that's going to be rolling out. So when we look at this down the road a little bit more, I think the need for public safety systems and the need to accommodate FirstNet is a discussion point that the industry will need to deal with, as well as the enterprise.
Now, do neutral host providers ever get involved with public safety, or only in commercial systems?
Martha, this is Ray. In my experience, I've not seen neutral host providers play in public safety systems, largely either cellular and or Wi-Fi deployments.
Right. Okay. Going forward, Scott, what role do you see neutral host providers playing in indoor deployments?
I think it's a fairly complex space, as we've been discussing here, in terms of making sure you have the optimal deployments indoors to achieve proper coverage and performance. So I think we can look at the American market in terms of the macro style backhaul providers, and there's, I would say, probably 70-something% of all macro sites are served through third-party backhaul, through wholesale alternate access vendors like the Zaos or cable MSOs or wholesale branches of the telcos. And I think indoors, this is the kind of thing where this play might repeat itself on a smaller scale. So neutral host providers can bring in infrastructure and manage that and share that across multiple operators, and also take care of things like connectivity into the backhaul in some cases that really bring the market to a more economical stage of deployment. So I think this kind of emergence and the maturity of neutral host providers and their offerings and their services is really going to ignite a lot more small cell deployments on the indoor space in the coming years ahead.
Let's hope so. Ray, do you have anything else to add on the neutral host topic?
Sure, just real quick to Scott's comments. I think that he was spot on. As the neutral host providers adjust their business model to the changes in technology, I think there'll be an increasing role here. And as they begin to embrace potentially more than just cellular deployments, they'll have more of an opportunity to manage, deploy, and maintain systems for the enterprise space where the ROI makes sense for all concerned.
Okay, well, we will have to wait and see. I know that new network architectures are also facilitating and bringing down costs of deployments. Scott, tell us a little bit about what you're seeing.
I think the role of NFV probably has the strongest effect in terms of how the network edge is being changed and things are being deployed. So clearly, if you're talking about the backhaul network or the small cell itself, whether it's or even a DAS environment, virtualizing customer edge equipment is becoming critical. We're seeing a lot more movement to that. A recent study by Heavy Reading said we had about 80% of all service providers that are bringing Ethernet backhaul into indoor deployments using a virtual customer premise equipment as a demarcation and monitoring point. So I think this is a real benefit to anything that's small cell oriented, whether indoor or outdoor, is that the whole spectrum of service lifecycle, network elements, and performance monitoring and demarcation units are all becoming virtualized to the point where the cost is, in practical deployments, 90% less than the equivalent standalone appliances would be. This comes along with service agility, of course, the ability to spin these instances up. If you're talking about monitoring equipment, often there's no need for additional hardware at the customer site. And also as things expand, as additional floors, let's say in an office building, increase their coverage, or as we start to actually work on in-air monitoring what the actual customer user experience would be at different locations in the building. All of these things can be added simply using virtual network functions from a centralized location, just the way that centralized controllers for the small cells and even Wi-Fi are becoming increasingly more adopted. So I think that's the biggest change in the network architecture that's just common across a lot of communication service providers' initiative at the customer edge.
Okay, you mentioned controllers used for Wi-Fi. Can the same infrastructure used for indoor small cells and even DAS be part of a Wi-Fi deployment?
I think so. I think in-building wiring, and I'll let our other panelists talk to that, and different Fronthaul technologies may be able to be reused for different parts of that. Definitely Wi-Fi is, I would say, less demanding in that it doesn't require any control plane or handoff type mechanics. It's usually simpler and coordinated between the units themselves as opposed to requiring a dedicated level of controller there. But the infrastructure for monitoring the connections and making sure that the end user experience is optimal, whether they're on Wi-Fi or LTE or on 3G, or as they move between them or different locations in the building, should be common to each, because they're probably all running back over a common backhaul, and that's really the point where you want to be able to examine the user experience from all the different media perspectives.
Okay, great. Ray, what have you seen?
Similar, actually, and I would agree with his points. And to add to that a little bit, I think that if you have a common infrastructure in the ceiling that is conducive to multiple technology deployments, then that's where it's going to start, especially from an indoor environment. From an antenna point of view, it's a question of frequency bands, and at Gatronics, we're obviously aware of that. So when we're looking at the KPIs for Visuar, for propagation characteristics, for bands that need to be deployed in a particular in-building environment, it's certainly doable today. And if you were to look at what's in the ceiling, and if it happens to be a fiber-based system that's in the ceiling, which a lot of the enterprises, the larger ones especially, are starting to deploy themselves, then the genesis is there to enable convergence, which speaks back to the potential ROI from the enterprise point of view.
Okay, great. And Earl, do you have anything to add here?
Yes, I do, Martha. I think if you look at some of the new RF DAS nodes that are being introduced by the vendors, a lot of them have a PoE port or Power over Ethernet port where you can certainly plug in a separate Wi-Fi access point, and then using the fiber allocate an Ethernet channel to do the backhaul of that Wi-Fi access point back to the controller. So you don't necessarily need to integrate the Wi-Fi capability into the RF DAS node itself, but you can plug in certainly a separate unit from a different vendor just using the PoE port, and then again allocating that Ethernet backhaul back to the system. And then if you look at picocells or other integrated small cells, most of them today that are being announced by the OEM vendors certainly include Wi-Fi as one of the air interfaces, along with 2G, 3G, and LTE as well.
Okay, great. Yeah, there's a lot going on there. Okay, we've got about 15 minutes left in our webinar, so it looks like we will not be able to share any audience questions during the webinar, but I have seen that some of you do have questions, and I encourage you to go ahead and send them in using your GoToWebinar control panel. We will share them with our panelists and try to answer them as we can after the webinar. At this time, we'd like to move on and talk about how indoor deployments are changing the skill sets required of the wireless workforce. And Alan, I think you have some comments to share on this.
Yes, thank you, Martha. So this is, as you say, I think to truly embrace scale, what you need is a deployment mechanism that is as simple as possible. So you can have you can de-skill the installation as much as possible and add, the complex design component part of that, and embrace that effectively through automation and capabilities such as SOM. This is certainly something which has been implemented within the small cell products, and I'm sure it's it's par and parcel of the DAS products that are there. And this is really par and parcel of this changing face of how you really look to drive larger volumes. What you're looking to do is to distribute the deployment burden, you could say, to multiple parties. So you could be in the situation where you're effectively sending small cell components to people to install themselves, right through to going through and doing a managed installation, depending what you're trying to achieve, and the complexity of that installation that you're looking at. This whole world of automation and virtualization that's happening in the network is bringing along great new opportunities for people to tap in to the information that's available within those network assets and really build new value-added services that sit within those systems that really help draw in the customers in the sense of helping them to be more effective in the way they run their workforce and their buildings as well. And this is something that you can definitely see in the market.
That's great. Well, we could do a whole other webinar on that. So hopefully at some point we will get to. How about the testing and optimization process? I know this is very different for indoor deployments compared to the macro network. Pierre, can you start us off talking about that?
Sure. For the pre-deployment testing of indoor and enterprise solutions, it is a little bit different than outdoor, we find, because certain aspects of it are just different. The interaction with the macro network is minimized in this case because you're protected by the building, so you don't have as much interference between the two layers. There are more core network components such as security gateways, small cell gateways, concentrators, etc., that come into the picture for an enterprise deployment. And also features like LIPA and SIPTO as well. They get into the act, and that changes where traffic is routed, etc. And then lastly, but certainly not least, the backhaul itself is potentially shared with tons of other types of traffic, bringing up, like was mentioned earlier, QoE type of issues. So as soon as your traffic is shared with other types of traffic, then that's worth a test or two.
Okay, great. Scott, do you have anything to add on this? Yeah, I think one of the main challenges indoor is that you have potentially numbers of connections going in from a central backhaul connection out to all these different cells that may be in the building, and they're all in fairly close proximity. So when you're looking at trying to isolate performance issues, it really requires a very high level of granularity in terms of precision, in terms of, let's say, latency analysis, because the latency differences inside an organization walls are probably down in the millisecond or microsecond range, whereas externally on a single link it would be a longer transit, so you'd have a bit less granularity potentially required there. But if you want to discover a problem or isolate it somewhere inside an organization where there's multiple very short hops, you have to be able to measure things very precisely. So that's one of them. And I think the other thing that's a concern indoors is that these are extremely dynamic networks. I mean, we all know that outdoor networks have peak hours and traffic demand at rush hour and so on. But inside a building, things can be very unpredictable. So if you have a large conference room, for example, that's suddenly occupied for a video conference and people are joining from there and from their desk, you get an extremely high degree of traffic flow that you might not get in a distributed environment. So what this requires is that you have also the ability in terms of granularity to measure things on a very fast timescale, so maybe on even a per second basis if required. That would allow any network controllers to do optimization and groom traffic over the most appropriate links to respond to these rapid increases in traffic demand.
Okay, great, thank you. And now let's talk a little bit about testing in the outdoor environment. How is that different from testing in the indoor environment?
I guess in the outdoor environment, you're going to use the similar tools there, but one thing that's a little bit more prohibitive is it's going to be harder to go out there and install new tools after the fact. What you really want to do in an outdoor environment is make sure all of your tools in terms of monitoring turn-up testing, bandwidth utilization, remote packet capture, synchronization testing. All those things need to be embedded into the outdoor housing with the small cell as close to the final endpoint as possible from day one of install. And that's logical because these tools can also help you do the turn-up testing and validate any problems that can happen as additional cells come online. So this is a case where highly virtualized solutions are almost necessary in terms of the cost value benefit, but also you still need to maintain the hardware precision in there to some degree to be able to isolate things like synchronization issues. So this is where a new breed of virtualized solutions using smart SFPs or very small NFV powered test modules are starting to become extremely popular. It's also because of their low power requirements to make them more attractive.
Right. Okay, great. Pierre, do you have anything to add on testing for outdoor small cells?
Yeah, again, we focus on testing before the deployment. So what's different about that is there's going to be a far greater interaction with the macro layer in this case. So it's typically a big interop issue. That's the biggest challenge with urban outdoor type of deployment. So those we've seen a lot of testing pre-deployment in lab testing to make sure that the macro layer is cooperating and acting nicely with the small cells about to be installed. So then you get into things like the X2 interface. SON gets far more active in this case as well. Interference testing if it's co-channel deployments, load balancing, etc.
Okay, all right, great. All right, we are looking at a picture here of a photo simulation of a Verizon small cell deployment planned in San Francisco. And we do want to take just a quick moment to review some of the cities that Verizon is targeting for its small cell deployments. Verizon seems to be one of the most proactive operators at this time with outdoor small cells. They are deploying 400 in San Francisco. Some of those are actually being deployed by Extenet on Verizon's behalf. The other cities targeted are Cincinnati, Pittsburgh, New York, Columbus, Cleveland, Erie, Pennsylvania, Palo Alto, California, and San Jose, California are also in the future. Those may not be quite as far along as some of the others, but these are the cities that Verizon has talked to us about to date, so we'll be keeping an eye on those. Now, one thing, getting back to San Francisco, I know it was much easier for Verizon because there was already dark fiber from a lot of the city-owned poles, and I'm interested in hearing perspective from the panelists on how dependent outdoor deployments are on access to fiber. And Pierre, I think you have some thoughts on that.
Well, my thoughts are a little bit future-looking in terms of virtualization in this case. The small cell forums done a lot of work to make sure that in the virtualized small cell use case, that hopefully fiber would not necessarily be a requirement. They're looking at Fronthaul with non-ideal type of requirements, non-ideal Fronthaul basically with reasonable bandwidth requirements and latency requirements that would probably not necessitate fiber.
Okay, well that's definitely something to keep an eye on. Aside from backhaul, there's also power, there's site acquisition. What are the other major costs associated with outdoor deployments? Scott?
I guess the biggest cost is probably installation, and once you have the site acquisition and everything else, really the installation of the small cell itself, bringing in the backhaul, making sure these things work properly together are major costs. But when you're listening at CTIA, as you mentioned, some of the operators talking like T-Mobile were saying that actually the cost of the backhaul itself was really a prohibitive factor that's delaying their introduction. So I guess the question here is how we can look at alternatives to fiber and how we can use multiple access mediums to get to small cells so that it does become a cost-efficient model for operators to work with. So these ongoing recurring costs are the ones that ultimately destroy their long-term profitability. And in this case, I think we're seeing quite a bit moving forward. We're seeing cable business service, cable backhaul over DOCSIS plants. We're seeing fiber to the home plants being used, RF. The only thing that's required here is when we're doing these multi-technology, sort of multi-protocol, multimedia style take what you can get at each site to make it cost effective, there really still needs to be some sort of uniform performance baseline, and that's what operators have to at least figure out a way to provide some uniform metrics and visibility regardless of which method they go to get there.
Okay, great. Now, Ray, what are you seeing with respect to cost? Ray, what are you seeing with respect to cost? Ray, can you hear
in
me?
addition to, yes, I can. Yes, Martha, can you hear me?
Yes, I can hear you. I was asking you what you're seeing with respect to costs associated with outdoor deployments.
No worries. And yes, the deployment cost is one of the major factors, labor being the large driver of that, obviously. And Scott alluded to the backhaul cost. But there's one thing that's embedded in all of this is that the time value of money. So the time from conception to implementation to getting recurring revenue back on the system needs to be shortened. It can take years and years to deploy San Francisco or any other major market. So in order for us to shorten that deployment cycle, all these factors in deploying an outdoor desk system, those timelines need to be shortened, and the technology that is here today can help do that. So labor and time value of money.
Okay, and I know the vendors are working hard to help with those as well as with the site acquisition process. Alan, what are you seeing vendors do to help operators with outdoor small cell deployments?
Well, that's a very good question, actually. I think what you're starting to see, if you take the example of some of the work that JCDecaux have done recently, which is very much looking at street infrastructure and in essence making that small cell ready. So making sure that whether it's a bus shelter, whether it's an advertising housing, whether it's a lamppost for street lighting or an information board, that there's space within those assets for a small cell that are in essence already pre-provisioned in order to make it easier to tap into any transport or power that may be available within those sites. And having a portfolio, JCDecaux are not the only company doing this, but but as these these assets in essence grow, that in essence helps one of the barriers that was being spoken about, which was really about finding the right portfolio of assets to enable small cells to be deployed quickly, to have that impact that you really want it to have. And in terms of the other work that the vendors doing, in terms of the technology that the vendors are putting behind, and in essence the SON capabilities that are underpinning the solutions, the ability for you to insert a cell, switch it on, and then with a few minutes for that cell to be active. Once it's in essence detected its own environment, reported that to the system, been provisioned with the right parameters to give you a high performing cell in your network. There are many vendors that are working to continue to build as LTE evolves to make sure that the SON capabilities form in line with that. And then there's a degree of, beyond SON automation that's also starting to take place. And when you're talking about automating, what you're doing is you're integrating all of your deployment tools, you could say, that you would have as a large-scale operator to deploy. So effectively activating the workforce to deliver the right equipment to a particular site, to make sure that gets installed, that all of these things become integrated and allow you to scale. And these are a number of trends that I see taking place within the industry, which are all helping to kind of break down the barriers associated around the major costs with doing these outdoor dense deployments.
That's great. Yeah, and some of the vendors I think are also working with some of those third parties, as you mentioned, like JCDecaux, I think is working with Alcatel-Lucent, and I believe Vertical Bridge has an agreement with one of the billboard companies, Clear Channel, so that the vendors can sort of help the operators understand where those assets may be, right?
Yeah, that's it.
Okay, great. I think we lost your audio for a minute there, Alan, but I think I heard you say something.
Yes, I was just agreeing with what you said, Martha.
Okay, great.
That's exactly right.
Well, we are near the top of the hour now, and so it is about time to finish up the webinar. So I'd like to thank all our panelists for today. Alan Law, Chair of the Small Cell Forum, it was great to have you on the webinar, and we really appreciated your comments. Thank you very much for being here.
Thank you, Martha, and we'll be, well, our next plenary is actually in Dallas, so hopefully we'll see many of you that are on this call today. If you're interested in small cells, we'll be presenting a number of our key pieces of work and our champions overview at the Small Cell Americas event, and then following that with our plenary event where we'll be effectively doing the detailed work of that. So hopefully I'll see many of you there.
Terrific. Okay, great. Earl Lum is president of EJL Wireless Research, our representative analyst today. Earl, thank you very much. We really appreciated your comments today.
Thank you, Martha, for having me on the webinar.
And Scott Sumner, it's always great to hear from you. Scott is VP of Marketing at Accedian Networks.
Thank you, Martha. And just as information, Cox, which will be working with us on their Small Cells as a Service project, will actually be demonstrating that capability live at the Gen 15 event. So if you're out and about traveling, there'll be an interesting live demo to see.
Okay, great. Thanks for letting us know about that. Pierre Lynch is lead technologist of Ixia's product management group. Pierre, thank you very much for your insights today.
You're welcome. It was fun to be here.
It was great. And Ray Hild is VP of Sales for North America for Galtronics. Ray, it was great. North America for Galtronics. Ray, it was great.
Thanks, Martha, and special thanks to everybody who took their time to spend it with us this afternoon. We appreciate it.
We do. We thank all of you that have been our attendees on the webinar. I'm Martha DeGrasse for RCR Wireless News, and this will conclude the webinar.